Okay, as you take out your notes, we just have two examples we're going to roll through. The rest of the time is going to be work time for you. Today's going to be a kind of a big teller about how well you use your work time because the assignment is definitely lengthy. That's why I try to build in some time. So I know it's Friday. If you're easily distracted, this is really going to hurt you today. So try to stay on top of it. We look at example B, f of x is equal to 4 over x plus 1 for a equals negative 2. My apologies. Yesterday I struggled a little bit trying to work through this problem because I'm trying to teach it kind of two different ways. So I've made a decision that I'm going to show you two different ways of doing it today, and you get to choose which one you want. Got it? So, yes, you go ahead. Fill in the all pass. I have f prime of a is equal to the limit as h approaches 0 of f of a plus h minus f of a all over h. What's that? We're doing letter B. So I write the limit as h approaches 0 of, what I do is I plug in a plus h for x. And when you plug in a plus h for x, e-hall pass, there we go, approve. Yep. More than YouTube really wanted to know. There we go. We get 4 over a plus h plus 1 minus, what do I plug in for the second part? Just a. What is f of a? 4 over a plus 1. All over what? H. So if you were to plug in 0 right now, you would get 0 over 0. That doesn't work out. I'm going to find common denominators. So I multiply top and bottom by a plus h plus 1 here. I told you we would be dealing with more algebraic structures during this unit. And this side, I'm going to multiply by a plus 1. And so I get the limit as h approaches 0 of 4a plus 4, then what? Good. I like that you're seeing that we distribute the negative all the way through. And the denominator, I have a plus 1 times a plus h plus 1. Now what? All over h over 1. If I multiply by the reciprocal, do you agree that the h is just going to join the denominator? So in these situations, I like to just join h in with the denominator. What cancels? The 4a's and the 4's. And the h will cancel as well. And when the h cancels, you know you can finally plug in 0 for the limit. We have the limit as h goes 0 of negative 4 over a plus 1 times a plus h plus 1. I can now plug in the 0 for h. When you plug in 0 for h, what happens? You get negative 4 over what? A plus 1 quantity squared. So that will tell me the slope of the line tangent if I simply insert my a value now. And what value are we trying to find the slope? Negative 2. As I put in negative 2, I get negative 2 plus 1 is negative 1. Squared is 1. Negative 4 over 1 is negative 4. So f prime of negative 2 is equal to negative 4 in this situation. Can I give you some context to understand if you did the problem correctly or incorrectly? Thank you for giving me that permission. 4 over x plus 1, I think everybody here knows that that's a vertical asymptote at negative 1, correct? And the graph looks something of this nature. So if you're looking at the slope at negative 2,
can you see that it is definitely going to be a negative slope? So thinking about the graph is an important step to understanding, is your answer correct? Here's another way to determine if your answer is correct. Take out your calculator. I'm going to show you something that you are going to love. Sam, you're going to be famous on YouTube now. Okay. Now, this is something that over the years I've had to show multiple times. You're going to use this throughout the entire year. So don't think that this is something that's just like, oh, Gens is trying to show something cool on the calculator. It doesn't mean anything. You're going to use this consistently all the time. 4 divided by parentheses x plus 1. We all know how to look at the graph, correct? Pretty close description of what I drew on the board, right? It's almost like I know what I'm doing. I'm going to show you how to calculate the derivative at a specific value. Remember what we did before is we wrote the equation for the line tangent. Remember that? That's how we checked our answer. Still a great way of doing it. But who wants to take all the time to write the equation for a line tangent? Second, calculate. Any guess? Don't worry, your calculator is too smart to show the asymptote line. Very good. dy over dx. That is the change in y over the change in x. The derivative. dy over dx is the phrase we use for derivative. So I select number 6. And you simply just identify the x value at which you'd like to find the derivative. What was the x value we had in this problem? So I type in -2, enter. It comes up with an estimation. Now, the estimation is accurate to about the 1/1,000,000th, but you can see that the answer checks out at a -4. Nice. So you were able to check and verify your answer this way. No, 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 no. Yes, sir. So, all right. Riker asked a really good question. And we're going to get to this question later on, but I want everybody to understand what he asked. Look at your equation right here. What value could you not plug in? -1. Does everybody understand you couldn't plug in -1? -1's not a concern to us anyway because the function's undefined at -1. Wherever the original function is undefined, the derivative is also going to be undefined at that same spot. It'll work out that way all the time. Flip it over, last example. I'm going to show you the second way of doing it, okay? So that's one way of doing it. Here's a different way of doing it, okay? Limit as h approaches 0 of f of a plus h minus f of a all over h. Remember last time we plugged in -2 at the end? If you want to, you can plug it in at the beginning. And if you did that, you would get the limit as h goes to 0 of, instead of plugging in a plus h, I'm going to plug in 12 plus h. So if you plug in 12 plus h for x, what are you going to get? 12 plus h minus 3. Minus, and instead of just plugging in a for the expression, you could plug in 12. And when you do, you get the square root of, which is 3. It's entirely up to you which one you want to do. This is the same as the limit as h approaches 0 of, we have the square root of 9 plus h minus 3 all over h. Notice if you plug in 0, you get 0 over 0. As we know, that will always happen with these type of problems. So what am I going to do to multiply by the conjugate? When you don't know what to do in math, do Spanish. Very good. And I get the limit as h approaches 0. What do you have remaining now? 9 plus h minus 9. Very good. All over. This is where people get sloppy in their algebra. You're not good enough at algebra to be sloppy with it right now, folks. Keep your stuff in order. H times the quantity, square root of 9 plus h plus 3. This is h times all that. The 9s are gone. You're left with an h on top, which will cancel with the h in the bottom. Agreed? So you're left with the limit as h approaches 0 of 1 over the square root of 9 plus h plus 3. I can now plug in 0 and not end up with 0 over 0. When you plug in 0, what do you get? 1 over 6. So notice in this situation, I ended up with a specific value. In the previous one, you end up with an expression, and then you plug in the value at the end. It's up to you which one you want to do. It really is. So it turns out that the slope at 12 is 1/6. Again, I'm just going to try to verify my answer to some degree. What does the square root function look like? And this one is shifted to the right 3 units. So you tell me, out here somewhere 12, do you think it's reasonable to think that that slope might be about 1/6? I think that that's reasonable. If you want to verify, go ahead and plug it into your calculator. Y equals, and I go the square root of x plus 3, minus 3. And we second calculate what? Number 6. It graphs it just as we had, and I plug in what? 12. And I get a problem. Why? Because my window is too small, exactly. So if I change my window so that I include an x value all the way up to, say, 20, now when I calculate number 6, so your x value must include that spot. So now I type in 12, and sure enough, it gives me 1/6. So I verified my answer. So you can check all your answers on your own today. The rest of the time is yours. Go.